On to part 3 for our final challenge in Excel. Notice on the left over here, it's asking us to sort our data. That's what this means by sorted. So we're gonna have to go get our data from above, copy and paste it here. We can go up and highlight our data. I'm gonna do it one at a time so I can sort them as well. If you remember, we learned sorting in our very first challenge. Okay, so I hit Control C. As a reminder, you can right click and copy as well. And then when we come down here, you can right click and either paste the values or Control V and it will paste them there. Okay, now to sort them, make sure you have them all highlighted. And remember, we can right click, go to sort, and then sort smallest to largest. We want to continue with the current selection. If you expand the selection, it'll start sorting things next to it as well. And these data values are just one data set, so we don't need to kind of expand how it's sorting. So we will continue with the current selection and just make sure that all of these are indeed in the correct order. Okay, coming back up here, we will copy and paste all of the data for females. So Control C or right click copy. And then we can come down here, right click and paste. Now that they're all highlighted, we can right click, go to sort, sort smallest to largest. And again, continue with the current selection. If you hit expand, it'll also start sorting the male data again in an odd way. So we just want to only sort what we have highlighted. So that's what that means. Okay, again, make sure that these are indeed in order and that it hasn't messed up kind of the formatting or anything. Okay, so once you have sorted all of this data, you can scroll down and it does indeed increase your score. So should be about to that now. All right, so once we have sorted all of this, we are running, in this case, a confidence interval. We're constructing a confidence interval for the proportion of females who speak more than 16,000 words in a day. So again, the yellow cells here, we notice will have drop downs you can choose. In this case, we're looking for the proportion of females. So what we're doing is trying to find an estimate for P, which is the population proportion. In this case, we're using a sample proportion, or P hat, in order to estimate the population proportion. So from this drop-down, we can select P hat. Again, that stands for the sample proportion, which is our point estimate when we're building a confidence interval. So scrolling down, we can make sure that that was correct, and it is. Okay, now we want to know the proportion of females from our sample who speak more than 16,000 words in a day. There are some little scratch notes over here to the right that can help you organize some information here. For now, I will focus on these because that's where we are looking at the female data. So into here, we are letting be the number of females. So we actually did calculate that earlier. If you remember, our count was 31 for females. So we can go ahead and type that in here. If you wanted to use that count function again, just to make sure that it was doing that correctly, please do. Okay, X2, they're referencing the number of females who speak more than 16,000 words per day. So we're trying to count how many women speak more than 16,000 words per day. So we can go find where that cutoff would be. And this would be the first person who spoke more than 16,000 words per day. And we can click and drag down to count how many. Now, I explained earlier, you can check down here. Notice it says count is 15. You can also highlight and use that count function if you would rather do that to make sure that it's counting correctly. I will come up here and type 15. Now these over here will not go towards your final score. It won't count these as correct or not, but you will be able to know if you were correct once you actually calculate this point estimate. So to calculate the sample proportion of women who speak more than 16,000 words per day, we can type equals. And over here, again, that 15 was that count. That was the number of people who identify as female who also spoke more than 16,000 words per day. So we can click on 15 or type 15. That is an exact value, so that would be fine to do that. I'm going to click on them just because I prefer to reference cells when I'm doing things. So this would be 15 divided by 31. And when you do that, we get 0.48 is our point estimate, or p hat. And if we scroll down and check, That is correct. Yay! All right. So that's our point estimate for the confidence interval. So now to build out our confidence interval, remember we need a margin of error. Our margin of error here for proportions is equal to, in fact, I'll write it above because we're going to use that area in a second. The margin of error is equal to Z alpha over 2, or our critical value, times the standard error. So we're counting how many standard deviations away we need to go on either side of the mean. Of the population proportion. If you remember to find Z alpha over 2, we talked about this in a lot of our pages with confidence intervals. You can use norm.s.inverse. So again, what that's doing is calculating a Z-score based on a probability to the left of something. If you remember from our pages, we've learned this to be, if the confidence interval is 95%, that means that the alpha, the leftover, is 0.05. And so we type 1 minus 0.05 over 2. So again, you're taking like the leftovers of the confidence interval and then dividing that into the tails. And that's why we're dividing it by 2. Okay, so this should be our critical value, or our Z alpha over 2. And that is correct. Alrighty. Now, with our standard error, as a reminder, I put down here, these are our test statistics. And so our standard error when we're running confidence intervals, we do want to use the sample proportion. So here, when we calculate the standard error, I'm going to come here. We can type equals, and again, we're looking at the square root of p times 1 minus p divided by n. Except we, again, for confidence intervals, we want to use p hat and 1 minus p hat. So here we want to take the square root of p hat times 1 minus p hat divided by n. If you, I need to click on n, which is 31. If you prefer to break this apart much more to get your standard error like from several steps in Excel, please do that. If you remember before, we really broke apart some math to make sure that we could condense it and get that correct exact answer. So, but again, this is the square root of p hat times 1 minus p hat, and these need to be in parentheses here to tell it that you're subtracting that first. And notice too, it's telling you exactly what that value is. That's cool. I didn't know it did that. Okay, divided by n. And we need to make sure that all of this is inside the square root. So notice the parentheses for the square root is totally around all of those things. Okay, so that is our standard error. I don't know why it was italicized. So now our margin of error is our critical value, which is Z alpha over 2, times this standard error. Okay, backtracking to make sure this is 55.9 right now. When I hit enter, that's our standard error, and it went up. So we are good. All right, so I'm gonna open this back up a little bit. I know that you can backtrack, slow me down, things like that, but I really want to, maybe I'll break this down in another way as well. So let's maybe take the square root last. So we could do p hat times, and again, you still need the 1 minus p hat. So you still need the parentheses around that. Otherwise, it will distribute things in an incorrect way. So you could do this first. If you wanted to find p hat times 1 minus p hat, you could do that there. Here we could have p hat times 1 minus p hat divided by n. So I came up and grabbed this n. Okay. Then we need to take the square root of it. So then we can take the square root of that value. And again, as long as you're self-referencing all of these, it's taking the exact values, and you can break it apart as much as you need to. So when we hit enter here, we should be getting the same thing that we got up here for the standard error. And we did. So however you want to do that, please do whatever works best for you. If you want to break that apart a lot, or if you want to do it all in one cell, go for it. So again, here we have the margin of error is equal to Z alpha over 2 times the standard error, which we just calculated. Okay. And that's our score now. Okay, so now to finish finding our confidence interval for the population proportion of females who speak more than 16,000 words a day. Our parameter, remember, we are estimating the population. So we're not estimating p hat, we're not estimating x bar, those are both sample. We are estimating a population value, always with confidence intervals. In this case, we're not working with means, we are working with proportions, so we need that one. We can come check, that was correct. Now with confidence intervals, our lower bound is our point estimate, so you can click on that cell. Again, don't type that. It won't calculate it accurately. It will be rounding things. So the point estimate minus our margin of error will find our lower bound for our confidence interval. Let's go check. Nice. And then we can take our point estimate and add our margin of error, and that will find our upper bound for this confidence interval. Ta-da! Okay, and as an interpretation here, what we're saying is we are 95% confident that the true value of the population proportion of women, or people who identify as women, speaks more than 16,000 words per day, falls between 0.31 and 0.66, meaning between 31% and 66% of women. And that's what our confidence interval is. If we wanted to draw this, basically, we have our point estimate here, which was that p hat. And then our confidence interval has built out this entire area. So within this area, we have 95% of a chance, basically. And then our 5%, our alpha, falls outside of that range. So what we've determined is that about, because those are rounded, between 0.31 and 0.66, we feel 95% confident, pretty confident, that the true value, P, population proportion, would fall between those values. Okay, we will come back in the next video to finish part 3. And again, let me know if you have any questions. Slow me down. Put me next to yours so that you can work side by side with me. Okay, I'll see you in the next video.